We all know that humans have had an impact on Earth's environment. It is common knowledge in the scientific community that carbon dioxide emissions from cars and pollutions from factories and cities are leading to the rise in overall global temperatures, causing more extreme weather. But do you know what else we've done? Though it has been studied very little, recent research indicates that human activity, such as making fertilizers and burning fossil fuels, has a huge impact on the functioning of the microbes responsible for processing the nitrogen in soil. So what happens to the nitrogen in soil? Nitrogen in the form of nitrate can undergo two reactions carried out by bacteria. Ammonification is the conversion of organically bound nitrogen found in decomposing organisms to ammonium, a compound of nitrogen that is readily usable for primary producers. This process is slower and less efficient than denitrification and therefore happens less frequently. The ammonium from ammonification is oxidized through the process of nitrification to form nitrate to be later used in denitrification. Denitrification is the reduction of nitrate to nitrogen gas, which is biologically inert so it won't react when it comes in contact with biological tissue. This reduces the amount of fixed nitrogen in the soil. Denitrification competes with ammonification to use nitrate as an electron acceptor, but denitrifying bacteria are often more abundant because denitrification is a much faster and more efficient reaction. But how do bacteria decide which reaction to carry through? There are three main factors that determine whether denitrification or ammonification will occur. First is the ratio of nitrate to nitrite. Nitrite can easily be converted to nitrate and vice versa. If there is already an abundance of fixed nitrogen in the form of nitrite that can be converted to nitrate, then denitrification will occur because the production of fixed nitrogen will not be necessary. Second is the carbon to nitrogen ratio. Denitrification will also occur if the carbon supply is limiting relative to nitrate supply. When nitrate is in excess, the bacteria will work to reduce the amount of nitrate in the soil through denitrification. When nitrate availability is limited, ammonification will occur to create more fixed nitrogen to carry out the nitrogen cycle. And finally, generation time, the time it takes the microbes to duplicate themselves. Slower generation time favors ammonifying bacteria because ammonification is a slower process, while rapid regeneration favors denitrifying bacteria. So what does this have to do with people? Naturally, there are low levels of fixed nitrogen in the soil due to lightning-catalyzed reactions and nitrogen-fixing bacteria. However, humans have created technology that can artificially fix nitrogen to be used in fertilizers. So you're a farmer and you buy lots of fertilizer to make your crops grow. You cover your fields with nitrate-filled fertilizer, but then it rains. Your fields are flooded and the water mixed with your fertilizer starts running down the hill into your pond, and before you know it, the fish in your pond are dead. What happened? Well, the nutrients in your fertilizer caused your pond to become nutrient-rich, which led to the growth of algae. When the algae die, microbes deplete the oxygen in the water to decompose the dead algae, causing dead zones. This is a process known as eutrophication. In addition, not all plants can flourish in nitrogen-rich environments, which means some species will be more successful than others. This increases the productivity of the plants that do thrive, but decreases the species diversity. But that's not all that's happened. Nitrogen fixation occurs naturally using nitrogen gas from the atmosphere. But with your fertilizer, you've already added the fixed nitrogen to the soil. You've already done the job of the ammonifying and other nitrogen-fixing bacteria. All that's left to do is the denitrification of the excess nitrates. So why is this significant? This is important because humans are responsible for the mass extinction that is currently going on, and it is because of activities like creating an excess of fixed nitrogen in the soil that is leading to the decline in species diversity. In addition, in areas where fixed nitrogen is in excess due to human activity, the bacteria that carry out ammonification are becoming obsolete. If humans continue causing an excess of fixed nitrogen in the soil, it could lead to the extinction of the bacteria that carries out ammonification, and natural production of fixed nitrogen will no longer be necessary.